Episode 2 of Chain Rule. Yes, you heard it right. Did you miss episode 1? Please don't worry. I made a link to the description of this video. Please check it out before you continue with this video. Hello friends, welcome to Caltex Academy. Today we are looking at differentiation of trigonometric ratio using chain rule. So please support this channel by liking this video, subscribe to the channel and share with friends to get notification for more interesting videos like this one here. And without further ado, let's get right into the video. Alright, in this question that says differentiate each of these function a y equals to sine 3x plus 2 in bracket. Now we're going to use chain rule to work out this differentiation. So the first thing is we can copy our question down here, and we have our y equals to sine in bracket 3x plus 2, and we can let theta as a new variable equals to what is inside the bracket, and that is 3x plus 2. So we can go ahead and differentiate theta with respect to x, and this results into 3. Then let's replace 3x plus 2 by our new variable theta at this side. So we have y equals to sine theta. Now this time around we're going to differentiate y with respect to theta. Then when you differentiate sine theta, we get cos theta. Now we can go ahead and state our chain rule that says dy by dx, which is the original expression from our function here, can be obtained by the two derivatives we have just got from the result of substitution of this theta by 3x plus 2. So we have here dy by d theta, and we multiply it by d theta by dx. So we can go ahead and replace dy by d theta by cos theta, and multiply this by d theta by the x, and that is 3, and it results to 3 cos theta. Now let's replace theta so that we obtain it in terms of x. So this implies that dy by dx equals to 3 cosine of 3x plus 2, and that is the derivative of the first function. Part 2, that is b, is equals to y is given by sine in bracket cos x, and we also go ahead and let a new variable, this time let's say u equals to cos x, and then we can go ahead and differentiate du by dx equals to a derivative of cos x is negative sine x. So this time let's replace cos x by our new variable u, and we have here sine u, and then we differentiate y with respect to u. So we have dy by du equals to the derivative of sine u is cos u. Now let's combine the two expressions here from these replacements using chain rule that states dy by dx following the original expression here equals to our first derivative dy by du times du by dx. So dy by du equals to cos u times du by dx is negative sine x. Now if we simplify this, we will obtain negative cos u sine x, and we have to write u in terms of x. Therefore, this implies that our dy by dx equals to negative cos, now cos x times sine x. Lastly, part C of this question is y equals tan into 5x minus 1, and we let I go back to theta 5x minus 1. So d theta by dx is given by 5. The derivative of this function just results to 5. So y equals to tan theta. And let's differentiate y with respect to theta. And the derivative of tan theta is secant square theta. Now we can combine the two expressions using chain rule. And chain rule also states that dy by dx equals to dy by d theta times d theta by dx. So replacing dy by d theta with secant square theta, and we multiply it by d theta and the x, which is 5, will result into dy by dx equals to 5 secant square theta. Now this is what we earlier on let, that is theta. We can replace it back to the original expressions of the function here in terms of y and x, which is x here. So we can go ahead and remove theta and replace it by dy by dx equals 5 secant square into 5x minus 1, and that is the derivative of the last part of this question. Thank you for watching up to this time. Please support this channel by subscribing to get notification for more interesting videos just like this one here. Share with friends, and see you in the next video. Ciao.